Hello, hi everyone. This is Tushar from Biotecnika. I welcome you all back to this session. In this session, we have been discussing this year NEET 2022 question paper. So in the previous session, we had a discussion on geology question, and I am back. And I'm back with chemistry questions with you. So please confirm if my audio is clear. So I hope you have done well in your exam. I congratulate to all those who have been preparing so rigorously for this exam. And finally, on the D-Day, on this exam day, they have done well. I congratulate them. All the best to you for your future endeavor. And for all those who have not done that well, please don't dishearten yourself. This is just an exam. You learn from your mistakes. Remember, there is one famous saying, either we win or we learn. So you recollect your mistakes, what you have done, and fortify yourself so that in the next exam, you come back stronger. So we'll wait for a couple of seconds. Do subscribe to the Telegram channel of Biotecnika. It has all the informations and notification regarding the latest classes and all. So you can take the advantage of that. So without wasting any further time, let's move to the first question. I'll be discussing the chemistry questions to be more particular with the physical chemistry and few concepts of organic and inorganic. So this is the first question. Given below are half cell reactions. These are the two half cell reaction that is given. The first one is MnO4 minus plus 8 proton plus 5 electrons, that gives Mn2 plus 4 water molecules. The reduction potential for it is given, where Mn2 plus is changing to MnO4 minus with minus 1.514 volt. And the second reaction is half O2, where half O2 is converted into water, and here also the reduction potential is given. The question is, will the permanganate ions MnO4 minus liberate O2 from water in the presence of an acid? So we want to know, will this MnO4 minus liberate this O2? Now, the most fundamental, you can use the electrochemistry most fundamental concept here for checking the spontaneity. So eventually we want to know that the combination of reaction is spontaneous or not. So what we can do? Good evening, Sweta. So what we can do? So we have MnO4 minus. So just check. So first just check MnO4 minus. So in MnO4 minus, what is the oxidation state of manganese here? So you can find the oxidation state of manganese to be +7. So eventually in this reaction, in MnO4 minus, it is getting converted to Mn2 plus. Mn4 plus 7 is getting converted to Mn2 plus. Okay. Now this is reduction. 5 electrons it will be taking to get converted to Mn. And the another reaction is O2, where O2, here the oxidation state in O2 will be 0, and it is getting converted into water, where the oxidation state over oxygen is -2. So it is getting reduced 2 electrons. Now, depending upon these values, depending upon the values that are given, this potential values, you need to decide which among them will be act as a cathode and which among them will act as an anode. So let's understand this. So what we have here potential for O2. Potential for O2 is plus 1.223 volt. This is the potential for O2 is given. And for the manganese, we have this. Now you need to compare according to Gibbs free energy. We know del G is equal to minus NFV. So for a spontaneous reaction, the del G, the Gibbs free energy, needs to be negative. And for that important thing, for that the E, the potential value, this E value has to be positive. So effectively, you have to find whether the combination of cells gives a positive resultant potential or not. That's the task you need to do here. So let's try and find it out. For manganese, For manganese, where manganese, let's compare the reduction potential. The more the reduction potential, the faster it will get reduced. So let's check the reduction potential here. So here manganese 2 plus, here manganese 7 plus. We are considering the reduction potential, checking the manganese 7 plus is getting converted to manganese 2 plus. So what will be happening? Addition of 5 electrons. So initially what is given to you? Initially it is given, initially you are given, this is the oxidation, standard oxidation potential is given to you. So you need to convert this. You just reverse the negative sign, use the negative signs and convert it. So the reduction potential for Mn7 plus converting to 2 plus is the, just reverse it with a negative sign, so it is minus 1.51, so it will be plus 1.51 volt. Okay, similarly you have the reduction potential for O2, it's given, it's plus 1.223 volt. Now compare which has the higher reduction potential. Definitely we can see it's manganese, so manganese will undergo reduction and this oxygen will undergo oxidation. That's what it is. So we want to liberate O2. So this reaction, this O2 reaction needs to be reversed, that we can see. So this will undergo reduction, and we know reduction takes place in cathode. So it will take place in cathode, and for this O2 it will undergo oxidation and takes place in anode. This is clear for everyone? So what we can do, just the simple thing. So we need to find the E0 cell. So E0 cell is the reduction potential for the cathode minus the reduction potential for the anode. So for the cathode, what we have, since this is the, we are given with the oxidation potential, just reverse, we have just reversed it. So this will be plus 1.51 minus, for the anode it's given, it's 1.223 volt. So eventually if we subtract it, we will be getting plus 0.287 volt plus, so we are getting a positive E node. So if we are getting a positive E node value, so this is a spontaneous thing. So yes, the answer is C. The answer is option C. Yes, MnO4 minus will liberate O2 and the E naught cell is plus 0.287 volt. Is clear for everyone? Answer C. Now moving to the next question. The next question involves the correct statement. See, while in this exam in NEET 2022, you can find that there were many questions were just tricking you in the statement that they have given. This correct, incorrect, choose the incorrect statement, choose the correct statement of the following. So it's an advice to everyone, while dealing with this question, have some patience. So read the statements properly. You should not make a mistake of the question that you are knowing well. That's the important thing. See, if a question you don't know, that's fine. But a question that you are knowing and you are making a mistake, that's a great loss for you in an exam. So what's the statement? The incorrect statement regarding the enzyme. So it's asking the incorrect statement regarding the enzyme. So let's check the option. What are the options present? So the first option says enzymes are polysaccharides. Now we know enzymes are proteins. Enzymes are made of mostly proteins. And the proteins are a combination of amino acid. So this statement, enzymes are polysaccharide, is a wrong statement. Enzymes, this is a wrong statement. Enzymes with polysaccharide is a wrong statement. So the incorrect statement that for enzyme is enzymes are polysaccharide. This is a wrong statement. Okay. Now let's understand the other options also. The next option is enzymes are very specific. Yes, they are very specific and very potent, very specific for a particular job. An enzyme which is catalyzing a reaction between A and B cannot be used for the other one. It is very specific and it is biocatalyst. That's what it does the job. It's a catalyst. It catalyzes the reaction. And how it does so? It reduces the activation energy. These are the properties. So when we say that the enzyme is increasing the rate of the reaction, the question arises now, how it does it? The answer is, it's by reducing the activation energy. So this option 4, option 3, where enzymes are biocatalysts, this is a true statement regarding enzyme. Enzymes catalyze enzymes, reduces the activation energy. This is also a true statement. Enzymes are very specific for a particular action. This is also a true statement. So what do we have? So the incorrect statement is only enzymes are polysaccharide. This is clear for everyone? So enzymes are polysaccharides. So this goes with option A. Now coming to the next question. Given below are two statements, one labeled as assertion and another labeled as reason. Now these assertion reasoning questions are very tricky. You need to have patience while answering them. So what is the assertion they are making? In a particular point defect, an ionic solid is electrically neutral even if few of its cations are missing from its unit cell. The assertion is in a particular point defect in ionic solid. Now it's a fact that all the ionic solids that we have are electrically neutral. We know this from solid state. All the ionic solids that we have are electrically neutral. So that's a true statement. And even if few of the cations are missing from its unit cell. So basically it is talking about Schottky effect. Basically, it's talking about Schottky defect. Schottky defect. It's talking about Schottky defect, where the cations and anions, equal number of cations and anions, move away from their lattice. So that's what it is talking. So this assertion is correct in a particular point defect. And let's understand the reason. In an ionic solid, Frenkel defect. Mark this. In an ionic solid, Frenkel defect arises due to the dislocation of cations from its lattice sites to the interstitial sites, maintaining overall electrical neutrality. This is a true statement because in Frenkel defect, we have the electrical neutrality. This fact is true. It is to be electrically neutral. But the important thing is the cations move away from their interstitial sites. So this statement is also true. So the assertion A and the reason R are both true. But let's see. Let's understand. Try to understand that is this an answer to this assertion? No, because Schottky defect is different. It is talking about when the cations move away from this lattice point. Okay, but Frenkel defect is different. It is moving away from the interstitial, from the lattice point to the interstitial areas. So these are two different things. So the assertion made, so reason R is not reason for this assertion. So let's see what we have. So both A and R are, what is the first option? A is correct, but R is incorrect. It's not the case. A is correct, but R is correct. It's not the case. Both A and R are not incorrect. It's not the case. The fourth option, both A and R are correct, but R is not the correct explanation of A. So I'm sure this is clear for everyone. So we will be having answer as option D, where both A and R are correct and R is the not correct explanation of A. Now moving to the next question. Which of the following PV curves represents maximum work done? Now, depending on these curves, you have to define or say which gives the maximum work done. Now, we know the PV work. We know the PV work. The PV work will be maximum. The PV work will be maximum when the area under the curve. When the area under the curve will be maximum. So, what is the case when we have maximum area? When we have maximum area under the curve. That's the case. In that case only we will be having maximum work done. So it was a very simple question. You just need to check the area under the curve. Now you can eventually see, you can see here the area, now here the area under curve is 0. Ultimately you can see this directly. Here the area under the curve is very less. But here if you see in option C, the area under the curve is larger in comparison to all the options. So for the maximum work done, what we need? Maximum area under the curve. Okay, so the correct option is option C. So larger the area under the curve will give us more work done. Okay, so the correct option is option C. Now moving to the next question, which compound among the following is not an aromatic compound? Now among these options, we need to find which is an aromatic compound. So it's important to understand first, how do we characterize or what are the characteristics of aromatic compound, or how do we identify an aromatic compound? So for an aromatic compound, it needs to be planar. The first thing is it needs to be planar. Second thing is it should follow or it should have 4n plus 2 pi electrons. So when we are counting the number of electrons, it should be come out to 4n plus 2 pi electrons. 4n plus 2 pi electrons. And the third most important thing is it should delocalize. So the electrons present should delocalize. They should be rotating, they should be delocalizing inside the system. So these are the criteria, these are the conditions you need to check for declaring a compound to be aromatic. So let's check this condition one by one in this compound and decide. So in the first compound, we have 6, 1 pi electron, 1 pi electron, so 3 pi electrons. So we have 6 electrons, but you can see here, they are not conjugated. Important thing, one more, is this need to be conjugated. They are not conjugated and it is not delocalizing. The pi electrons cannot delocalize. So among the following, this compound is not an aromatic compound. Why? Although it has 6 pi electrons, which follows the Huckel's rule, but the important thing is it is not delocalizing. So we don't have delocalization of electrons over here. It's not conjugated. Okay. Now let's have a look on the other options. Now if we look to this option, cyclopentadiene. So here we have 2 plus 2, 4 electrons plus this negative anion will give 6 electrons. So the 6 electrons are present. This is a planar structure and this can be delocalized. We can see how it is delocalizing. So this is delocalizing. So this is an aromatic compound. If we look here, we have 1, 2, 3 pi bonds, so 6 electrons. But important thing is, due to the presence of this carbocation, what will happen? These electrons can delocalize. They can delocalize like this. They can delocalize. So delocalization can take place. So hence it is aromatic in this case also. So if you put n to be 0, you'll be having or getting 2 pi electrons. So here we have only 1 pi bond. So this will giving 2 electrons. So this 2 electrons, since there is a carbocation over here, there is a positive charge here, so it can delocalize. So hence this is also a aromatic compound. So what we have? So we have only this. This is a not aromatic compound. This is not an aromatic compound. So the option is A. Option A is the correct one. Now moving to the next question, match the list. List 1 and list 2 are given. In the list 1, we have lithium, sodium, potassium hydroxide and cesium. And list 2 contains some of their functions. So we need to match list 1 with list 2. Now let's try to see this. Now we know lithium. Currently we have been using various phones and all. So you might be very familiar with this term where we do generally hear about lithium ion batteries. So without knowing anything also, out of common sense itself, you can say that this lithium will be used in electrochemical cells. Because we have heard a lot about this lithium ion batteries and all. So lithium will be going with electrochemical cells. Now you have sodium. Now the sodium does what? Sodium is used as a coolant in fast breeder reactor. Sodium, it's very good in absorbing this heat. So sodium is used as a coolant in a fast breeder reactor. Sodium hydroxide. Now the sodium hydroxide is used as an adsorbent for carbon dioxide. So basically sodium hydroxide reacts with carbon dioxide to form calcium carbonate, and which in turn will further react to form calcium bicarbonate. So this is even a method. Where you can test quantitatively the dissolved carbon dioxide in a solution or something. So KOH is used as an adsorbent for carbon dioxide. This is a true statement. We can connect that. And cesium. Now cesium is used in various photoelectric cells. What are photoelectric cells? These cells convert solar energy into electrical energy. So as we know, electrochemical cells, what does that do? They convert what? They convert chemical energy into electrical energy. So similarly, photoelectric cells convert solar energy into, or the light energy into the electrical energy. So the cesium is used in photoelectric cells. So what do we have? So we have here, let's try to correlate. So we are having D4. Let's check this. D4. What do we have? D4. This is the option that we are having. Okay, so this is the option that we are having, where we are having D4, where cesium is a photoelectric cell, lithium is a A3, A2. Lithium is electrochemical cell. So this is option A. So the correct option for this is option A. Okay, moving to the next question. Now, again, we have some statement-based question where the first statement is the acidic strength of monosubstituted nitrophenol. The acidic strength of monosubstituted nitrophenol is higher than phenol because of the electron withdrawing nitro group. And the second statement is orthonitrophenol, metanitrophenol, and paranitrophenol all will have the same acidic strength as they have one nitro group attached to the phenolic ring. Now we have to say depending on whether the statement 1 is correct, statement 2 is correct. Now let's try to understand what is happening in there. So the first statement says the acidic strength of the monosubstituted nitrophenol is higher. This is a true statement. This is a true statement because in case of phenol, we have this OH group. But in case of nitrophenol, monosubstituted, it can be substituted anywhere. For the convenience, I am substituting in the ortho position. But what is this NO2 group? What is this NO2 group? This is a minus R group. So through resonance, it will pull the electrons out of the ring. So what it will do? It will pull the electron. It's an electron withdrawing group. Nitro is an electron withdrawing group. So it will pull the electron density from the ring. Now for acidity, the acidity strength. So what is this acidity strength? Basically, it is the ease of the molecule to give out its proton. So let's say we have phenol. If it is giving its proton, so eventually it will be developing a phenoxide anion. Now, based on the stability of this phenoxide anion, if more the stability of the phenoxide ion, the compound can more easily give the proton. So it will be more acidic. So that's the concept we need to use here. Now, this anion, this negative charge will be much more stable if we are having an electron withdrawing group. So here we have a nitro group. So if we are having an electron withdrawing group, that will decrease the electron system from the system. So more this negative charge, this negative O minus, the phenoxide negative charge will be much more in conjugation in the ring. So it will increase its stability. So more the electron withdrawing group present, so it will increase more stability of this, so it can easily donate the H+. So that's the concept that we need to use here. So the acidic strength of monosubstituted nitrophenol is higher. This is a true statement as I've explained. Now in the next statement is saying ortho, meta and para will have the same acidic strength. The important catch is this nitro group is the OH group we are having over here. Just let me clear this one. The OH group that we are having here, is a ortho-para directing group. So the acidity is influenced by only the groups attached at the ortho and para position. If the group is attached in the ortho or the para position, it can only affect the acidity. If it is attached in the para position, it cannot so, because it is not in the conjugation. Because if we try to delocalize and see it, it is not in conjugation. So if a nitro group attached in the meta position, it does not deactivate the ring. So it cannot stabilize the thing. So the acid strength of ortho, meta and para will never be same. It is important. So it will never be same. So the statement 1 is correct. But the statement 2 is incorrect. The statement 2, we can see the statement 2 is incorrect. So what we have? Statement 1 is correct. Option D. We have the option D, where it is statement 1 is correct and statement 2 is incorrect. Now moving to the next question. Which one is not the correct mathematical equation for the Dalton's law of pressure? Partial pressure, where P is the total pressure. Now it's asking on Dalton's law of partial pressure. So it has given various expression, and in that, see again I'll say here, note what it is. Which one is not the correct? So NTA is playing with these words. So while solving this question, you need to be very careful. Which one is not the correct mathematical equation for Dalton's law? Now let's first understand what does this Dalton's law state. The Dalton's law states the partial pressure, just changing, the total pressure will be equal to the partial pressure of A plus partial pressure of B, but This partial pressure of A is given by the total pressure into the mole fraction of gas A. This will be given by the mole fraction of gas A. Now, similarly for this, total pressure into mole fraction of gas P. This is important. So the total pressure is given by PA plus PB, if we're thinking that there are two components, A and B, and the partial pressure of A will be given by the total pressure into the mole fraction of that gas A. Suppose we are talking about PA, so it is total pressure into mole fraction of gas A. Okay, so this way we can find. So let's go through the options. So the first option is the pressure for the ith gas is the mole fraction of the ith gas into P. This is the correct statement, what we have seen, where P is the total pressure. So if we are trying to find out PA, the partial pressure for any unit or any gas or the ith gas will be given into total pressure. What is the total pressure that we are talking about? Here the total pressure is P. Here the total pressure is P. So total pressure is P into mole fraction. So this is the correct statement. Now let's move to the next statement. The next statement states Pi, the partial pressure of the ith unit of gas, is equal to Xi, the mole fraction, into, it's saying, the pressure of the ith gas in the pure state. This is wrong. We need to always consider in Dalton's law when we are considering for the partial pressure of a gas, particular unit constituent PA or PB, it is in respect to the total pressure PT. So what we have discussed here, PT, the total pressure into mole fraction of that gas in the mixture that we have. So this is a wrong statement. This is a wrong statement. So what we needed to do, we wanted to find the incorrect mathematical equation. So the option 2 is an incorrect mathematical equation for Dalton's law. Now let's see the option 3 and 4. Option C is correct, where it talks about the total pressure. It's the sum total of all the partial pressure. If we have three constant, it will be P equal to P1 plus P2 plus P3. It's correct. It's a correct statement. Now coming to the fourth option. Okay, the fourth option is an alternative way of writing or expressing the third one. So I'll just show how it has been done. So for the Dalton's law, we know the container is same. The container is same. The container is same. In the same container, we will be having different kinds of mixture of gases. The container is same, so the volume will be same. It is important. So the volume will be same. The V is constant. So the volume is constant. So you see here RT by V. So what is changing? Only the number of moles. Depending on the number of moles will be changing. So what we know from the ideal gas equation, we know PV equal to nRT. So what will be pressure? So pressure is nothing but N RT by V. Simple. P pressure is equal to N RT by V. So just since V is a constant, RT by V at a given temperature will be constant. So we will be having this. So what is the changing only thing? The number of moles. So this is different way. This is a different way of expressing the option 3. So among these options, we got the incorrect statement is this option 2. Option B is the incorrect statement. Okay, I'm sure this is makes clear. So the option 2 is the correct answer. Now moving to the next question. This was the most easiest question in this paper, where in 1 molar solution that contains 0.5 moles of solute, so how much solvent we need? Just it's a very simple formula based, very basic question they have asked. So they're asking that in 1 molar solution of 0.5 moles of solute, how much solvent needs to be there? So what we know, we know molality. Molality is given by, what does the definition of molality say? It says the number of moles of the compound that we're taking divided by the weight or the mass of the solvent in kg. Mass of the solvent in kg, or otherwise you can take in grams and multiply this. In case if you are taking in grams, so this will be moles upon grams into 10 to the power 3. You can do your wish. So it's basically number of moles of the compound that we're taking divided by the mass of the solvent in kg. Okay, now what they have given, they have given us 1 molar solution, and how many moles do we have? We have 0.5 moles. So if we are taking the mass of the solvent in kg, so solvent in kg, if we are taking the mass of the solvent in kg, so what it will be? Solvent in kg, so it will be basically 0.5 kg. 0.5 kg is basically 500 grams. Okay, so the correct option is option D, 500 grams. So we know molality equal to number of moles upon mass of solvent in kg. Just replace and substitute it. It's a very simple formula based question. So if anyone has done their basic well, they will surely have got this answer correct. Okay. So the correct option answer is 500 grams of solvent. So that's option D. Okay. Let's move to the next question. Now the next question is, it's a simple question from stoichiometry. What mass of 95% pure calcium carbonate will be required to neutralize 50 ml of 0.5 molar HCl solution according to the equation? So they have given an equation here. They have given an equation where calcium carbonate is reacting with HCl to give calcium chloride, carbon dioxide and water. Now they are saying that what mass of calcium carbonate will be required so that it neutralizes 50 ml of 0.5 molar HCl. Now the first task that you want to do here, you want to calculate the number of moles present in 50 ml of 0.5 molar HCl. That's the first task that we want to do. Okay, so how do we do that? So number of moles of HCl that we are talking about, simple, number of moles of HCl will be given by concentration that we have, concentration into volume if we do. So what is the concentration that they have given? 0.5 molar into what is the volume that we are seeing? 50 ml upon 1000. So that will be 25 divided by, so just let me cancel this. So it will be, just let's cancel this. So it will be 25 upon 1000. So it will be 0.025. 0.025 moles we have. Just check this calculation. It will be 0.025. Okay. So the number of moles that needs to be here is 0.025. Now, for this, you can see from the stoichiometry, 1 mole of calcium carbonate neutralizes 2 moles of HCl. So if we are having 0.025 moles of HCl, so how much calcium carbonate would have been used? So the half of it. So we would be having half of it. So basically the calcium carbonate that we have is 0.0125. 0.0125 grams will be having this. Okay. Now this is the number of moles that we'll be having. 0.0125. This is the number of moles we will be having. Now what is the molecular mass of calcium carbonate? The calcium carbonate we want, what do we want? We want in grams. You can see the options are in grams. So just multiply with the molar mass, molecular mass. So we will get the mass in grams, converting moles into grams. So just multiply with 100. For calcium carbonate it's 100. So if you multiply with 100, it will be 1.25 gram. Okay, it will be 1.25 gram. So the calcium carbonate, supposingly considering that we have 100% pure calcium carbonate, we would have required 1.25 gram. Now in the question there is a trick. It is saying we have 95% pure calcium carbonate. So what we have achieved, so what we have got, so we have got 1.25 gram. So 1.25 gram of calcium carbonate, but this 1.25 gram is basically 95% pure. This 1.25 gram is basically 95% pure. So you can either solve it through the elementary method, or you can just use this key. We have X amount, let's say we have X amount of this, and it is 95% pure, and this 95% pure is giving 1.25 gram. Now if you solve for X, you will be getting the answer to be 1.32 grams. 1.32 grams. So we will be having here 1.32 grams. The correct option is option C, 1.32 grams. So the concept was here to first find out the number of moles involved in the reaction, the number of moles that we are using in HCl. Now depending upon HCl, you need to decide how many moles of calcium carbonate will be required. Now the question asks says that it is 95% pure. So accordingly, you have to calculate for 100%. So this is how, yeah. And the correct option is option C, that is 1.32 grams. Moving to the next question. Which of the following is suitable to synthesize chlorobenzene? Which of the following is suitable to synthesize chlorobenzene? Now we have 4 options here. Among that, we need to decide which combination will give us chlorobenzene. So let's try understanding this. The first option, we have aniline. In the first option, we have aniline. In the first option, we have aniline. Now this aniline in the presence of HCl, this aniline in the presence of HCl, if you're treating it, since aniline has this lone pair over nitrogen, this aniline has this lone pair over nitrogen, so this lone pair will attack with this proton first. This lone pair will attack, this lone pair will attack in this proton. So this first they will do acid-base reaction. So after this acid-base reaction, we will be having protonation over this plus, and chlorine will be the counter ion. So this is what will, so this is, you can see this is not forming chlorobenzene. So this can be the option. Now moving to the next option, where benzene plus chlorine in the presence of anhydrous FeCl3. Anhydrous FeCl3 is there. Anhydrous FeCl3 will be reacting, and this will be giving. So this reaction, this is a very common reaction, electrophilic substitution reaction. Electrophilic substitution, and we know this will give us chlorobenzene. And what does this happen? In the first step, this chlorine reacts with Fe chloride, Fe3 chloride to form the Cl minus. Cl minus will be attached to this, so we'll be generating basically the chlorine cation, Cl plus. So this electron rich aromatic system, benzene, can react to undergo electrophilic substitution reaction. So using this we can form the chlorobenzene. Now coming to the third option, when phenol is reacted with NaNO2, it does not give diazotization reaction, rather it will form a blue color complex which is due to endophenol. Due to endophenol, this will form a complex basically in the first step. Basically, when we are reacting phenol with NaNO2, in the first step, nitrosophenol is formed. In the first step, NO group it attached. Nitrosophenol is formed. That's important. Nitrosophenol is formed. So this will be eventually not forming chlorobenzene. That's the important take-home message that we're taking from this. And in the fourth option, that is benzene with HCl. See, this won't react because this HCl is an ionic thing. So this Cl minus will be there, but this benzene is electron rich, so this can't attack. So this reaction can't go. So which of the following is suitable to synthesize the chlorobenzene? So the correct option for this is option 2, where benzene with chlorine can form in the presence of anhydrous ferric chloride. So the correct option is option C. Okay, correct option. Now let's move to the pH of solution containing 50 ml each of 0.1 molar sodium acetate and 0.01 molar acetic acid. Now this is a question from ionic equilibrium. So I expect all of you have done this. This is a very basic question that we generally get from ionic equilibrium. Now you can try this question along with me and involve in solving this question where the pH of the solution is given. Now what we need to use here, we need to understand how this pH and the concentration of this acid, sodium acetate, and this is linked. So this is linked via, we know, pH. Just let me change the ink. So pH is equal to pKa plus log of salt concentration divided by the acid concentration. Salt concentration divided by the acid concentration. So we have everything that we need. Okay, it is also given as the pKa. It has also given us the pKa. So the pKa is 4.57. It is given. Just the formula based question. Now we have log. Now the salt concentration, what we have, sodium acetate is the salt here, is the salt here. So basically the combination of this, if you realize properly, the combination of this will give us an acidic buffer. So we will be getting an acidic buffer. We will be getting an acidic buffer. We're getting an acidic buffer for this. So the salt that we have, what is the concentration of the salt? So 0.10. And what is the concentration of the acetic acid? 0.01. Now if you solve this, this will give 4.57 plus log 10. Now we all know the value of log 10, it's 1. The value of log 10 is 1. So the final answer will be 5.57. The final answer will be 5.57. So the correct option is option C. So the correct option is option C. So the important thing was to know this equation which correlates the pH with the pK. Now moving to the next thing. Which among the following is incorrect statement? So we have few options here. And among these options, we have to say which option is correct. Sorry, which option is incorrect. Again, they have tricked here. They're asking which option is incorrect. So when you're picking the option, be careful. So what we have H2 plus. We have H2 plus. So when we are discussing for H2 plus, it's saying 1 electron. So it's true. It's true. In H2 plus, in H2, so basically, this is the molecule is written slightly, it's a typo. So the molecule is basically H2 plus. So 1 electron it's losing. So what we have? So molecule is basically, I'll just rectify this thing. The molecule is basically, it's H2 and it is losing 1 electron. That's the thing. H2 and it is losing 1 electron. So in H2, we will be having 2 electrons. So since it's losing 1 electron, we will be having H2 plus will be having 1 electron. This is correct. Now again in the second, it is O2. It is O2 plus. So again, this is there is a typo. This is O2 plus. This is O2 plus. So the question is O2 plus is diamagnetic or not. So we know for elements or for the electronic configuration where n is greater than equal to 14, where n is greater than equal to 14, if we arrange the MOT of the things of the orbitals that we have, so we will be having 1s is less than sigma 1s will be less than sigma star 1s. Similarly for 2s, sigma star 2s. Now there is important thing for greater than 14. For greater than 14, we will be having first the sigma orbital. So first sigma 2pz will come, then this will be less than sigma 2px, which is equal to 2py, and which is less than sigma star 2px into sigma star 2py to by sigma star 2pz. Okay, now just we have to fill up the electrons. So since in O2 we have 16 electrons. In O2 we have 16 electrons. Since 1 electron is lost, so it will be 15 electrons. It will be 15 electrons. So if we just count here, 2 electrons, 2 electrons, 2 electrons, 2 electrons. Here we have consumed 8 electrons. Here 2 electrons, 10 electrons, and here 4 electrons. So 10 for 14. So here we will be having 1 electron. Now what is the meaning of diamagnetic? Diamagnetic means when all the electrons are paired. So we can see here there is a single electron is present. So this is not diamagnetic. So this is paramagnetic. This is not diamagnetic. So if you want to choose the incorrect statement, this is the incorrect statement. This is the incorrect statement. The option 2 is an incorrect statement. So it is a diamagnetic species. Now if we just closely check for this bond order of O2 plus, O2 plus, O2. So these are correct. It will be 2.5, 2, 2.1.1 and 1.5 respectively. For C2 also similarly you can just arrange. Just I'll say if n is, so it is for n greater than 14. For this we can use for n greater than 14. For n less than equal to 14. The above the thing expansion for MOT that we did, that was for when the electrons are greater than 14. For electrons less than equal to 14, you can just do one change, where here what does it happen? Here the p orbitals, where the sigma comes first. Where the sigma comes first, then the where the pi comes first. Sorry, where the pi comes first. So we will be having, what you will be having, I'll just write it down for you. When n is less than equal to 14, for finding the configuration in option 4, what you can do, the same thing, 1s will be there, 2s, 1s, where 1s sigma will be there, sigma star with this, similarly for this, which is less than pi. Pi to px is equal to pi to p. Y is less than sigma to pz. This is the only change, other thing remains constant. So you can put this and find this is also a correct statement. So what we have, the only incorrect option that we have, what is being asked is option 2. Option 2. I'm sure this would clarify this question. Moving to the next question. The given graph is a representation of kinetics of a reaction. So they have given us a graph, and it says the y and x axis for the 0 and the first order reaction are respectively. So if we have a graph where y is represented and x are represented by various things that we'll see in these options, now which of this will be correct? Now let's check one by one. Now for the 0 order reaction, let's read the first statement. The 0 order reaction, in y-axis if we have rate, in y-axis if we have rate, in y-axis if we have rate, in y-axis for 0 order reaction if you have rate and concentration, this is true. This is a true statement, because for 0 order reaction the rate is independent of the concentration, so it's a constant flat line. But the second statement, first order rate is not a constant with this thing, because t half is a very constant number, it's fixed, so this can't be the thing. Let's move to the next thing, where concentration and time, in 0 order the concentration and time thing is there, but in 0 order also the concentration decreases with time, so this cannot be a thing. What do we see here? We see in the graph that in the y-axis this line is parallel to this x, so this means that whatever factor is coming in the y-axis will be a constant with respect to x. So on that basics, on that logic, we have to find this. Okay, so this won't do the job, because it is given concentration versus time, because we can see that it's a constant, but in 0th order reaction the concentration versus time graph is a decreasing thing, so that's not the option that we have got. Now we can check for this one. Here again the 0 order concentration versus time, this won't do the thing. And let's move to the 4th option. In the 4th option it says 0th order, where y is represented by rate and x is concentration. So y is rate, x is constant, that we have already seen. It's a flat line. Now next check for the first order reaction. For the first order reaction, it is given y is the t half. Y is the t half, and it's given concentration. Now for the first order reaction, what do we know? This is a very important thing that we learn in the first order reaction. For the t half, in t half, the first order reaction, it is 0.693 by k. This is, we know. So its t half is a constant. T half is a constant with respect to concentration. So it will be a straight line. So which graph? This will be representing option 4. This graph, the correct option for this is option 4. Okay, this clears the confusion. So this is option 4 is the correct answer to this. Now moving to the next question. The incorrect statement regarding the chirality is, so there are 4 statements, where the first question is, again they have written here incorrect statement. They are asking for the incorrect statements. Okay, so the incorrect statement regarding the chirality is, enantiomers are superimposable mirror images on each other. The first option itself is a wrong statement. What do we know about enantiomers? Now enantiomers are mirror images, that is true, but they are non-superimposable. The fine example is our hands. If you have these hands, now you can see these are mirror images, but if you try to overlap them, they won't be overlapping. So these are enantiomers. So the first statement which says enantiomers are superimposable mirror images, they are mirror images, that's true, but they are not superimposable. It's a non-superimposable mirror images. That's important. So this is the incorrect statement. Now let's go through the other options also. The other option are a racemic mixture shows zero optical rotation. So this is true because in racemic mixture we'll be having both the R and the S configuration. So if one is rotating towards the right side, polarized light, the other will be rotating the other side. So hence the effective optical rotation will be zero. Okay, for a racemic mixture it is zero. This is a crude statement. For SN1 reaction, it's 1:1 ratio in both enantiomers. This is true because generally in the SN1 reaction, what do we get? We get a carbocation intermediate. Mostly we see that. So in that case, both the phases are now applicable. So the reactant can come from the anyway. So we'll be getting two enantiomers and they will be in 1:1 ratio. So this is also a true statement. And the fourth option is the product obtained by SN2 reaction is inversion in configuration. This is true because in SN2 reaction, the reactant attacks on the backside and the leaving group moves from the front. So there is an inversion in stoichiometry. So this is also a true statement. So the question is the incorrect statement regarding the chirality. So the incorrect statement regarding the chirality is given by the option 1. Option 1. So option 1, enantiomers are superimposable mirror image. This is the incorrect one. Okay, this clears this question. And let's move to the next question. Now the next question is at 298 Kelvin, the standard electrode potential of copper 2 plus, zinc 2 plus, Fe2 plus and Ag2 plus to Ag are given. So these are the potential that is given respectively. On the basis of the standard electron potential, predict which of the following reaction can occur. Now the very first question that we picked up in this session was again a similar concept. So effectively, whenever they are asking you for predicting whether this reaction will work, whether this is spontaneous and all, you should keep in mind that for such reaction, E cell should be a positive thing. So when you're comparing these reactions, try to figure out where this E cell will be a positive thing. Now just let's analyze this option. Now what we have copper 2 plus 2 copper, it's 0.34, and we have another option where Ag plus 2 Ag, it is 0.8 volt. These two things we have. Again we have zinc 2 plus 2 zinc, it is minus 0.76 volt. Again we have Fe2 plus 2 Fe, so this will be minus 0.44 volt. So while analyzing this, while considering this, you need to check for which we have the positive E value. Now, if you clearly check each options, so what we have, so you see here, what is this happening? You can see here where Ag in solid state 0 is getting converted into +2. So it is undergoing oxidation. This is one thing. So, and here we have copper 2 plus, where this copper 2 plus is getting to 0. So it is getting reduced. So this Ag is getting oxidized, and let's check that if we are having a system where we have copper and Ag, which will do what? So if we are comparing the reduction potential for copper 2 plus to copper is 0.34, and for Ag plus to Ag it is 0.84. So which will be more feasible? For Ag we have Ag plus to Ag, so which will be more feasible? So Ag plus, so this will be more feasible. This Ag plus will be reduced first because it has higher reduction potential, but you can see here what is happening, it is getting oxidized. So this is not possible. So in similar fashion, you can check through all the options and decide, and you will get the same thing. You need to check where we are having the positive E value for the reaction. So where comparing, you can use this concept that higher the reduction potential, that will be reduced and the other will be oxidized. This is the fact that you need to keep in mind. So the correct option for this will be option A. So this is how we have completed 15 questions in this session, and I'll be back again with some more questions in chemistry, where I'll be explaining in detail this year question paper, NEET 2022. Till then, take care and revise all the questions that we are having. And to everyone who have done well in the exam, again congratulate you. And to all those, please, who have not done that well, please don't dishearten your heart. You have another chance. You can do better, much better. You know your potential. Just work hard and you'll get it. Now, please subscribe to our Telegram channel for Biotecnika. You'll be getting more notification, you'll be getting more important links, so you can avail these facilities, you can avail this knowledge that we are imparting. Thank you all. Take care. Bye-bye.